One.
All right, welcome. This is one of the final videos I have planned. One of the final ones. There might be a few more coming afterwards. We're going to make a USB head. So like what you plug into your USB outlet for your mouse or whatever else it might be, the cord connection for that. Lengthy video, a lot of steps, follow closely along, and we'll get right down to it by doing a sketch in our top plane. So in the top plane, I'm going to view that top plane right at it. And the sketch is going to be a simple center point rectangle with the center right on the origin. All right. And the dimensions of that rectangle is going to have a length of 1.26 and a width of 0.59. And we're going to call that USB head because this is the main part. And I'm going to go ahead and label the rectangle dimensions just as a way to verify that I have gotten everything right. Like I said, there's a lot of steps. We want to take our time, make sure things are correct, and that'll save us some troubleshooting in the future. So we have that named, rectangles fully defined. Go ahead and hit your green check mark, and then we're going to extrude that a distance of 0.28. So Shift E on your keyboard, the shortcut for the extrude tool. And once you have that extrude open, you can select that you want to extrude the USB head. You can say that you want to extrude the head 0.28 and you name it USB 0.28. We'll add head, USB head. And I'm going to put depth 0.28 because that's what it actually is. So we know that's an extrude by the symbol. When we know that's a depth of 0.28. The next thing we're going to do is create the little cutaways in the corner of your USB. So you can look down at your mouse right now and see that it's got these little corners cut away on the USB head. So the sketch for those is going to be right here on the face of the extrude USB head depth 0.28. So click that face, select sketch, and the sketch is going to look something like this. We're going to start with a center line going across it. We will be using a lot of reference geometry in this project, so be sure you keep it labeled as such. What we're going to do is just draw one side, and then we're going to mirror that over. So draw the lines like this, developing the relationship with the edges that they need to have, being coincident. This line should be horizontal, and then of course this line just needs to be coincident to this edge here. Turn on your dimension key and set that dimension at 135 degrees for that angle. The next dimensions you'll want will be the distance from the edge here of 0.1, and then you will want a distance of this length of 0.31. There we go. So now, like I mentioned, we're just going to mirror this over. So let's select the mirror button up here, and then go ahead and select your mirror line, and then select these two objects here, and you can see they just pop up right on the other side, fully defined, ready for us to go. So we're just going to call this the Cutaways sketch and hit check. We should be good to go ahead and extrude remove these things, I guess, these cutaways. What that's going to look like is hit the extrude button, remove, select this region, select that region as well. Go ahead and select through all for the removal, and then we're going to name that just cutaways, remove. And there we go. We've subtracted those corners from the piece. We are beginning to see this USB head take shape. So the next step is to start the little cord protector that ends up on the end of where the cord goes in, that kind of shock absorber thing, if you will. And so what we're going to do is get yourself looking at the left face here and you're going to do a sketch right on this face. So have that selected, select sketch, should be on the face of USB head, depth of 0.28, and select your circle. What we want is that circle to be right in the middle, but since we don't have a center point given to us right here, let's go ahead and add a reference line in so that we should have something like that. See how I can now select the midpoint? So make that reference geometry because that's what it is. And then now we can go ahead and add our circle. The center point should pop up as an object we can snap to, and then you can bring that out. This will be actual geometry, so change that back if it's in the reference geometry. Still make it actual geometry. And we're going to give that a diameter of 0.24. So turn your dimension key on and make that say 0.24. And we're going to call this a chord protector sketch. I'm just going to put depth or diameter of 0.24. There we go. Oh, shucks. We're blue. I actually struggle when this happens. Oh. I don't know how I highlighted. That didn't do it. This will do it. Still recording? I'm going to go ahead and name that chord protector diameter of 0.24. And I'm going to hit check. And then the next thing I'm going to do is I'm going to extrude that sketch right here. So Shift plus E should turn on the extrude. It knows that I want to extrude that because I had it selected before I hit extrude. We are going to add a solid material, and we're going to extrude that a length of 0.55. And we're going to give it a draft. What that means, you can see by the preview, is it's going to taper it automatically for us at a degree that we set. So we're going to set that at 2 degrees, but your chord doesn't get bigger as it goes out. It gets smaller. So flip that arrow around so that it's shrinking. Once you have that, we're going to go ahead and just name this chord protector extrude. Or chord protector, we can conclude it's an extrude from the symbol on the toolbar. We're going to put add length 0.55 and a draft of 2. There we go. Again, these complex titles are in some cases a level of overkill. In our case, they are very useful, and both making sure that we are putting in the right input as a way to kind of check ourselves, and also when it comes to troubleshooting some issues, it's very handy to be able to scan the design tree and see what steps are actually taking place when and where, and give us a little bit more details than just the symbols that are automatically provided to us. Extremely helpful, yes, but no reason to not help ourselves out even more. So now what we're going to do is sketch the area where the cord actually comes out of that little shock absorber. So do a sketch right on the face of that chord protector. And it's going to be a similar sketch as last time because you're just going to add a circle again. You want to make sure that circle is in the center point, which should be provided for you. And then once you have that circle, you're going to give it a diameter of 0.12. And then just name this chord diameter 0.12. And then go ahead and extrude that chord. So select that new material. You're going to add it. It is a solid. And you're going to extrude it a length of 0.8. So face of chord diameter. I'm just double checking some things here. And I'm just going to say chord extrude 0.8, depth 0.8. And there we go. We are really beginning to see this take place. Now, the next thing we're going to do is create the little symbol that is oftentimes found on a USB head. And what we need to do is create a recess at the top of the USB head. All right. And if you look at your USB head and kind of run your fingernail along it, you'll see what I mean by a recess. It kind of dips in. There's a symbol printed on that depth in that comes back kind of up, embossed, I think is the term. And then the recess is there to make the symbol more legible, I guess. So what we need to do is draw that recess. And we're going to do that right on the top plane here. And we're going to start by drawing a center line from end to end. So create a sketch, click this face as the plane, use your line tool, connect midpoint to midpoint. It should go right through the origin. Make that a construction line. Once that's a construction line, you're going to use a center point rectangle. You're going to make sure that the center point is coincident with that construction line you just created, but not the origin. Don't develop any relationships with the origin. And make it look like so. And then we're going to give it a dimension of 0.39 and 0.57. So this width will be 0.39. And then this length here will be 0.57. All right, and the last thing we need to do is tell it how far it's going to be from the edge to get it fully defined. So click edge of the rectangle to the end of the USB head and enter a dimension of 0.16. Now we have a fully defined USB head recess of 0.57 by 0.39. And hit check. What we're going to do is go ahead and extrude that. We're going to remove that, a total depth of 0.02. So that's just going to look like this. Extrude, remove, depth 0.02. And just name that recess, remove, depth 0.02. Hit check. And what you should end up with is a little divot there, just like your USB head that you're looking at. Now that we have that, we're going to start the symbol sketch. And there is a level of complexity to this. And so what we're going to do is we're going to start by starting a sketch right there in the bottom of that recess. I'm going to view it right at that. And I'm going to create a center line from midpoint to midpoint. I'm going to call this reference geometry. And then I'm going to go ahead and offset that line at 0.1. Sometimes what I do is I get issues with double clicking this offset dimension when there's other things. So a lot of times I'll drag that all the way out and then go ahead and enter my offset dimension just so I'm not interfering with a bunch of other things. So that also needs to be a construction line. So make that so. And then we're going to offset the other direction as well. Select your offset tool again, select this line, move that arrow this direction. You can see that face that's selected because I had to double click there. And we got 0.1 there as well. Just because we don't like those blue dots, let's go ahead and make them coincident to the edges. Just to have everything fully defined, make sure all 3 lines are construction lines. What we're going to do is add a circle on this one, add a triangle on this one, add a square on this one, and then add a bigger circle on this one. So add a circle right on the origin. We'll start with that and give that a diameter of 0.1. And then go ahead and add another circle here and give that a diameter of 0.06. And let's go ahead and get that circle fully defined. So select that center point, select this center point, make sure you get a horizontal dimension and set that horizontal dimension to 0.33. Okay, step 1 is complete. Let's move on to step 2, which is a triangle. So what I've done is I just drew half the triangle by creating a line perpendicular to that center line and then bringing that point up like so. And then set this dimension to 0.03. And then set the total height of the triangle to 0.05. All right, now we're close to being fully defined, but we're not quite there yet. So let's see, what is it that is still going to move? Well, we know the dimensions, but it isn't locked in place as far as left to right. I was hoping to click and drag it, but I think I'm having issues. So to lock it in place, what we're going to do is tell it that it has to be, I'm just reviewing my notes here. I'm trying to see where I labeled it. Okay, there it is. The peak of the triangle needs to be 0.43, it almost is, away. Now we have half a triangle fully defined. Well, technically, I guess it is a triangle if you count the center line as part of it, but let's go ahead and use that center line as a mirror line. What that'll look like is we'll come up here to our mirror tool, we'll select the mirror line first, and then we'll click these entities here. And so now we have a triangle ready to go. Now that that's done, all we need to do is add a center point rectangle over here on that line. Once we have that center point rectangle, we're going to give it a dimension of 0.06 by 0.06. The rectangle will become a square. Yes, a square is a rectangle by definition. And then it needs to be locked in place. So we're going to locate it the same distance away from the origin as the circle and make that 0.33. All right, we have all of our symbols fully defined. The only thing we are going to have to do is add the channels that go to those symbols, but let's go ahead and just do that as a separate sketch. So we're just going to call this USB symbol sketch and hit check. Excellent. The next thing we're going to do is extrude that up to the face. So we actually haven't done this yet, but it's relatively simple. You're just going to do your extrude, you're going to do add, and you're going to go ahead and select these symbols that we created. And then instead of just making them grow to a predetermined dimension like we usually do, all we're going to do is select up to face and then just select that face. And what that'll do is guarantee that even if we change this recess or change the dimensions of the USB head itself, it'll always make sure that these symbol faces are flush with the face of the USB head. And we'll just call that symbol add up to face. And you can see the symbol starting to take place. Now let's go ahead and do the sketch for the little lines that go. One line goes straight to the arrow, one line does the little angle up and over, then one line does the kind of down angle and over. In fact, if you want to just look at your mouse, you can see that symbol. So we're going to go ahead and create that. And it's going to be on the same face. Just do a sketch. We could have done it in the last sketch, but there got to be where there were so many lines and so many things going on. It's just easier if we kind of broke it up a little bit. So we're going to do a sketch in this plane. Let's get looking right at it. And we're going to start by making the center lines that need to happen. So use our line tool, draw a line coming from here to the midpoint there, and draw a line from the center point here coming back about 2/3 of the way. And then make it coincident with that line and do the same thing from the center point here, a horizontal line coming up at an angle almost at the halfway point, but maybe don't snap it onto the halfway point. And then all of these lines need to be construction lines because they're actually just the center of the pass that we want to create. So change all those to construction lines. And then let's create an offset of these lines of 0.1. So I'm just going to select all lines. No, it won't let me do that. It'll let me do this one. Okay, it'll only let me do those two at one time. And I'm going to just enter 0.1 as my offset, 0.01 as my offset. All right, and then that did create a little of an issue over here, but that shouldn't be a big deal because it is blue. What it did was just tried to automatically adjust for us based on, I'm not sure, but let's go ahead and offset this the other direction. And one thing I've started to do, instead of trying to always flip this arrow and deal with accidentally selecting the wrong things, I will say this feature I find to be kind of bulky to use compared to SolidWorks, is I've started to enter negative 0.01. So instead of clicking that arrow to flip the direction and then dealing with the issue of trying to select the right things in this mess, I've just pull it straight up again out of the model space. And then if I want it to go the other direction, I just enter negative 0.01. And what that'll do is offset it on the other side, that center line. So again, we did run into an issue where it thinks that it's got to automatically change the dimensions for us, but that's not anything we can't handle. So once we have that, we're going to do the same thing to these lines as well. Oh boy, I'm not sure what's going on there. I'm just going to go ahead and do these one at a time. I know it's bulky, but it just may be less bulky in the long run. So there's one line. Then I'm going to offset this the other direction, 0.01. And again, I'm just going to enter the negative 0.01 to get it going the other way. We have that one done. Now all we need to do is these two. I've just been turning my offset tool on and off. I want to say there is an easier way to do this. If you know it or think of it, please share. Excellent. Now what we need to do is just kind of clean up this diagram. So we need to trim up pieces and then extend pieces. So let's start by just selecting trim. And what that's going to do is just cut these little tails that don't need to be here. This really only needs to be one closed boundary. So we can even cut out that middleman there and cut these tails as well. So take some time, go through, make sure you get everything cleaned up using your trim. I'm just going to leave that there. It won't let me select that because that's part of a different sketch. I had forgotten that we did it that way. All right, excellent. I think that's everything. I'm going to go ahead and trim these pieces. Oopsies, no, I'm not. Again, I forgot. What I assumed was it would trim it to the edge of that circle. And what I've neglected to remember was that circle is part of a different sketch. So it's not going to recognize that. Okay, so that cleans everything up. I'm going to turn off the trim command and turn on the extend command. Because I misspoke. It doesn't clean everything up. We still got this goofy corner here. So if you just hit the extend command and then click the line you want to grow, click the line you want it to grow to, it'll automatically grow and put those together. You may have found that you had different corners, not quite that you matching up with mine, that you may need to extend or trim differently. Just get yourself to the point where nothing is left behind. I'm going to go ahead and drag these blue points coincident with that circle, as well as these ones. The center of the reference geometry I can leave as is. And we almost have our symbol completely done. The only thing we need to work on is we have this sketch here that's still blue. The reason it's still blue is it doesn't know what angle it needs to be at. Remember when we first started sketching it, moved it way out of whack. Kept the relationships coincident, but still moved it way out of whack. So we've got the angle for that one. Let's go ahead and set the angle for this one. I'm just using the center lines and creating an angle of 60 degrees. And then we need to just let it know where it needs to be locked in space. So what I'm going to do is just say that the distance from here to here is going to be 0.1. So the distance from the origin to the center line here will be 0.1. Right, and then let's just go ahead and lock this center line. I know I said we weren't going to do it this way, but let's just go ahead and use that midpoint. So I'm going to go, ooh, there we go. I just locked it vertically underneath that midpoint, and then now everything is black except for these dots, which we can make black by selecting them and choosing to have them be coincident to the end of the symbol there. And there we go. Now we're going to do the exact same thing. I'm just going to call this symbol sketch 2. You can see how busy it was just going to get with both of them in the same sketch. And then hit check. And then we're going to do the exact same thing. Extrude the material up to face. You can select these boundaries and select this face. Oopsies, not that face, this face, that outer perimeter there. All right, so when you turn it at an angle, you should be able to see that it's extruded to be flush with that outer edge. And we're going to name this symbol extrude, symbol add to up to face. And there we go. We're done with that USB head. All right, now we're going to go ahead and do I call it the male insert, the connector that sticks out of this end. So we're just gonna view on this plane here, the right plane, and select that face to start a new sketch on that. And you're going to sketch a rectangle that has the dimensions of 0.16 by 0.47, and make sure it's a center point rectangle, because what we want to do is, before we use that center point rectangle, is give us a midpoint to reference. So we're going to draw this line, make it reference geometry, and then we should be able to snap right to the midpoint of that line and draw this rectangle with the dimensions of 0.16 by 0.47. And then what we're going to do is use our favorite offset command again to move those lines in 0.2. Now again, I'm just going to put negative 0.02. I misspoke. Negative 0.02. Oops, and I got 2 points. Negative 0.02 to move it in that way. And then we're going to do the same thing for this line, negative 0.02. And then let's see if we can do two at once. Nope, it's just not going to do it. Oopsies. So that one I entered negative 0.02 and it went the wrong direction. So I'm going to double click that 0.02. Okay, you have to have the offset command turned off in order to change that dimension. 0.02, I guess in that way that's similar to a smart dimension. And then do the same thing for this line as well. And it's just going to be a 0.02. Awesome. Now we have an inner boundary, and what we're going to do is just trim that up. And then we're going to go ahead and extrude that sketch. Once we name it, male insert sketch. We're just going to name it male insert 0.47 by 0.16 inner offset of 0.02. Now we're going to go ahead and extrude that. So select that, and more or less you want to select the shell of that. You're going to have this hollowed out portion. And we're going to extrude that a length of 0.47. And we're going to call that just male insert add depth 0.47 and hit check. And so now we have that taken care of. The next thing we're going to do is put the little square prongs that you see on the top of this. So go ahead and get looking at the top, select this as your sketch face, start a new sketch. You're going to add a center line, and then going horizontally. And then add a rectangle, center point rectangle on one side. Because what we'll do is we'll just end up mirroring that. And those have a dimensions of 0.08 for the width and 0.1 for the length. So this right here, this horizontal, is going to be 0.08. And then this length right here is going to be 0.1. Awesome. Now we just need to set it as a distance from the edge. So make sure you select the center point and this edge, because it is to the center of that, you get 0.24. All right, and then we need one more dimension, and that is going to be from the center point to the center line. That's going to be a dimension of 0.11. And then now go ahead and create a, not offset, but a mirror. Select your mirror line, and then select these objects. And then we should be good to go with this sketch, which we will call connector prongs. I don't know the technical term for these. If you do, please share. And I'm just going to put 0.08 by 0.1 and hit check. And then we're going to do an extrude remove. Let's just name this from the start. Connector prongs remove up to next. So you have an idea of what's coming here. We're going to select this region and this region to remove. And we're just going to select up to next. And what that'll do is just remove it up to the very next surface, the very next face, which is just that part there. And so you should see that it couldn't, you can kind of see through those prongs at the right angle. Awesome. Now the next step here, I've got to believe it's done because somebody was modeling this as they went and kind of added this step in, which they could have done in a former step. In fact, there's a couple of steps you might notice as you've been following along that you're like, why didn't we do this in the last step? We had a little bit of that with the symbol sketch, and there's been a few other instances you'll notice where that might be a thing. And the best I can understand is these are tutorials I'm using from solidworkstutorials.com, and sometimes they are missing a little bit of information. And the best I can understand is maybe the guy was just modeling it as he was measuring things, like very proactive reverse engineering style and not like design intent style. And those are two different types of styles you would utilize. So this step that we're about to take, we could have done when we went ahead and extruded this feature. As best as I can tell, I can't see why not. And if we were in a designer's shoes, that is kind of what we would want to do to make the model just easier for any engineers or anybody else dealing with it down the road, all the way down to the point of the manufacturer dealing with the model. So I won't make this video any longer than it already is, but what I would like to do is add a sketch. Select that kind of shell that we created, and let's add a sketch. It's just going to be a rectangle. I'm just going to go from here to there, and don't lock it to that midpoint. I accidentally locked it to that midpoint. So what I'm going to do is go ahead and select show constraints, select that midpoint relationship, and delete it, because we want to be able to adjust that height to the dimension of 0.04. All right, and then now what I want to do, mine shrunk, yours might not have, because when you did yours, it may have automatically developed this coincident relationship between those two lines. Mine didn't, because it developed the midpoint relationship instead, and then I deleted that. So nothing we can't handle. And then I'm just going to call this connector bottom, and I'm just going to give it a height of 0.4 in the title, and select check. And then we're going to extrude that, and it's just going to be a solid. We're going to add it. I'm going to go ahead and title it connector bottom add up to face. And I'm going to select that 0.4 rectangle. I'm going to have it go the other direction, so it's going inside of that. And then I'm going to select up to face, and And then I'm just going to select this interface in here. And what that'll do is just give us that rectangle going all the way back to that face. And then hit check. And then so now we have that more accurate representation of that USB connector. Once that's done, let's go ahead and fillet everything. That'll give us a little break from some of this layout, and everything else. These are pretty basic operations. And what that's going to look like is just select your fillet tool and go ahead and select every object of your main body head. And you're going to make those 0.04. I'm just going to name it main body fillets. And select every edge going around. In the side view, on the top view, in this side view, and then the bottom view. This is where it can get kind of confusing. But if you miss an edge, you can always just double click on the feature and edit it. Let's see, did I get everything there? Might be easier once I hit the check mark to see. And it looks like I did. All right, then we're going to do the same thing just to these ones here. So hit the fillet command again. And we're just going to name this connector fillets. And they're going to be the same dimension, actually, of 0.04. And we're just going to do the corners of that connector. And there we go. So we have all those fillets done. All right, moving right along now. We are going to work on that chord protector. And this is kind of an interesting process here. So what you're going to do is go ahead and do a sketch on this, on the end of that chord protector. So not the end of the cord, but the end of that chord protector. I want you to do a sketch on that. And what that's going to look like is you're going to start by drawing a rectangle, just kind of in this like quadrant here. So like right here in that quadrant. And then you're going to go ahead and also draw a couple of center lines from here to here on the end of that chord, and actually bring that all the way up to the end of that chord protector. Okay, make that reference geometry. And then same here, come from, see, this midpoint over, so that we have these center lines helping us out here. And you're going to set this rectangle a dimension of 0.03 away from the edge. And then you're also going to do the same here. So that rectangle kind of comes in at that angle. Now what I'm going to have you do is go ahead and trim these lines here. But before I have you do that, we're going to go ahead and convert or use this circle here. So turn on your use button, click that circle. That'll project that to the plane, that shape to the plane that we're currently drawing on. And then go ahead and trim the outer arch of that circle. So what we want is that rectangle to be whole, except it's got this little arch cutting into it. And then let's delete that corner. That arch is going to become the kind of bottom corner of what was formerly a rectangle. And so what we end up with is that kind of look, that thing cornered there. So what I'm going to do, oopsies, don't want to trim that. Undo. Forgot I had the trim thing on. And what I'm going to do is just tell it that that has to be coincident with that circle. That way it's fully defined. And then these can actually be turned into reference geometry. They're not really going to be used in this step, but because we want them black, let's just give them a dimension of 0.3 and a dimension of 0.3. Great. And then that should give us everything we need to kind of make the cuts that we're going to make at the end of that, give it that shock absorber look. So I'm just going to go ahead and call these relief cuts because they do help the end of the chord bend. And I'm just going to call it Chord Protector relief cuts. And this is the sketch. And then now I'm going to go ahead and create a plane for this. And that plane, I'm just going to go ahead and offset that plane. So select new plane. It's going to be an offset plane from the edge of this. And we want to go an offset of 0.04. I know all this right now probably seems like, what the heck is going on? But just bear with me here. We're going to turn off the front, top, and right plane just to make things a little easier to visualize so that I can see where this new plane that I'm adding actually is. And for some reason, I'm not getting a preview. It's not letting me. I think that's because I have an edge selected instead of a face. So let me try and select that as my face. There we go. And I can see this little plane popping up right here, plane 1. And we're just going to name that the relief cut offset plane of 0.04. All right, and then what we're going to do is we're going to do a new sketch in that plane. All right, and then what we're going to do is actually take this arc, this line, this small arc, this line, and use that in that plane. So we're sketching in that plane, that relief cut offset plane. We're going to select use, convert, and then what we're going to select is this, this, and this. And actually what we can, we're not going to select that major arc. Instead, what we're going to do is select just the rectangle pieces because it really doesn't matter. And there we go. So that's all we need to do. That's in that new plane now. And we're going to call this relief cut sketch. This is the actual relief cut sketch. We just project it onto that plane so we can start that relief cut a little off into the distance. And then we're just going to do a remove depth of that sketch of 0.04. So relief cut, remove depth of 0.04. And you'll really see what we're doing now. I'm trying to move quickly so you can kind of see exactly what's going on. I know this can be a little bit confusing, but it'll click really well when it does. And that's what I mean, right there. Now look at the end of your USB cord. You should see exactly what it is I'm talking about now. And then just hit check. And we have that first relief cut. Now I can ask you while I prep for the next steps, how you think we're going to get it to look more like that USB cord. If you notice, there's multiple relief cuts going down the line, and there's also multiple relief cuts around the whole chord, but we've just got one here. So what are we going to do to make it more than one and more accurate representation of an actual USB chord? Well, what we're going to do is create a linear pattern first. And that linear pattern, this is going to be a two-step operation, is going to be a feature pattern. And the feature we're going to select is this cut, the relief cut remove depth of 0.04. And then the direction can be pretty much anything that's just moving in that left-right direction. and our instant count is going to be 8, or I'm sorry, 6. Our distance is going to be 0.08 inches. Right, and we should get a preview generated, and we do, and this is great. This technique actually worked really well. You can even see with that draft how the cuts get bigger as they get closer, which is a really nice realistic touch. So we're going to go ahead and call this relief cuts, distance of 0.08, and I'm just going to put 6x to tell us that we've got 6 of them doing that. And so now, how do we get those same features to go around, around like it does on your USB cord? Well, we're actually going to create a pattern of a pattern. So this is a really cool step as well. And then we're done, ladies and gentlemen. We have made it to the end of this video. I don't know how long it is, but it will be a whopping number of points for you in the grade book. So let's go ahead and do a circular pattern of the relief cut of the linear pattern. Only make sure it's on feature pattern. Again, we have to feature the pattern the feature. So features to pattern, relief cuts, and then you can see those are highlighted. We can select this circle as our axis. And notice that it popped up in the features to pattern. We don't want that. So go ahead and exit that. It'll be the top one. So your top features pattern should still say relief cuts distance 0.06 6 times. And I just noticed an error there, but let's fix that later. Let's do this axis. And we end up with those 4 cuts going in a circle. Instance count should be 4, 360 degrees, equal spacing. We're just going to name this relief cuts times 4. And then we're done. The error I noticed here is I put 0.08 and I titled it 0.06. So I'm just going to go ahead and edit that. 0.08 is what it's supposed to actually be. Awesome. And so now we have our USB cord all done and taken care of.